Dear students, here I come with another video. The topic for today is algorithms and flowchart. Chapter number 4. The video is for class 8. So students, can you think of a day in your life that goes without problem solving? So is there any day that has gone without solving any type of problem? The answer to this question is no, because every day, whatever activity we do, whatever activity, whether we are going to school, whether we are taking our breakfast, or whether we are going for a ride, whatever activity we do, this activity can be considered as a problem. And then when we complete this activity, that means we have solved this problem. So there's not a single day in our life that has gone without problem solving. So all these activities, it involves a series of steps in a sequential order, and then finally we get the desired output. That means sequentially we follow the orders one by one, we follow the steps one by one, and then finally we get the output. Let's take an example of the process of brushing the teeth. Right, first what you do is take your brush from the shelf. After that, turn on the tap of the wash basin. Third step, rinse the brush and turn off the tap. Fourth step, apply toothpaste on the brush. After that, you start brushing. Then after you finish brushing your teeth, you rinse your mouth. All right, you clean the brush. Then you take the tongue cleaner. Right, you clean your tongue. Again, rinse your mouth, and finally you get the desired output. That means you get a white shiny teeth. So here what happens, what did you do is you followed a sequence. Step by step. You followed a sequence for brushing your teeth, or you followed a process for brushing your teeth. So similarly, in the computer also we need to give the instruction to perform a specific task. For that, we give the instruction in a stepwise manner, and this giving instruction in a stepwise manner is called program or computer programming. So this chapter is very important before you learn the computer programming. Our next chapter will be computer programming. So because of that, we will learn this chapter, and you will understand how to follow the sequence, right? How to perform the task in a stepwise manner, so that it will be easy for you to practice the program or learn the programming language. Algorithm. So what is an algorithm? To solve any problem in a computer, we need to analyze and understand the nature of the problem. So if you want to solve any problem in the computer, first we need to analyze the problem. So what type of problem is that? You need to understand that, right? You need to understand the nature. You need to analyze the problem. Only after that we can solve the problem in the computer. So we plan input and apply the required method step by step to get the desired result. So we plan input as well at the same time. So if you are performing an addition, you need to have the numbers, right? You need to have the operators, right? Only after that the stepwise method is performed. Step by step the method is performed, and then finally you get the desired output. So the step-by-step process to solve any logical and mathematical problem is called an algorithm. So whatever problem you solve in a step-by-step manner, it is called an algorithm, whether it is a logical, whether it's a mathematical. So rules for writing algorithm. An algorithm should be written in English-like language. So why do we use English-like language? Because it becomes easy for the user to understand. Second rule, it should be written in simple and precise manner so that everyone can understand. So it has to be very simple, it has to be short. so that everyone can understand. Number 3, an input is required to write an algorithm. As I've mentioned before this, if you are performing an addition, you need to have the numbers, you need to have the operators. Only after that you will get the output. So in order to write an algorithm, you need to have an input. Fourth one is, one can include variables and define mathematical expressions to calculate the result. So variable means you can assign a character, a string where the data can be stored. For example, a plus b equals to c. So the value for a can be given as 2, for example, or the value for b can be given as 3 equals to c. So whatever 2 and 3 gets added, that is a and b gets added, and then finally it is stored in c, that is 5. So a, b and c is your variable. So we can include variables in an algorithm to calculate the result. The fourth rule, to ensure that algorithm produce the expected output, it should be checked using a sample value. As I've told you, like if you have given a plus b equals to c, so you have to check it with the sample values. Like I've told you, for a we have given 2, for b we have given 3, and finally the output, that is c, becomes 5. Characteristics of an algorithm. A good algorithm should have the following features. Number 1 is input. So as I've told you, we need an input. The algorithm also accepts the input. Number 2, generality. An algorithm works on a set of inputs. So if you're performing an algorithm, if you're writing an algorithm, there has to be an input. It works according to that input. Definiteness. Number 3, each instruction should be written in a simple and precise manner so that everyone can understand it. So definiteness means, so the algorithm has to be in a simple, it has to be written in a simple manner, it has to be written in a short manner, precise manner, so that everyone can understand it. Uniqueness. Each step in an algorithm should be uniquely identified, and an output of each step should depend on the previous step. So it has to be dependent on the previous step, that means. So it has to be uniquely identified. Each line or each step in an algorithm has to be identified uniquely, and the output should be based on the previous step. Finiteness. It should involve finite number of steps to reach a solution. So you cannot have a very lengthy algorithm. You have to have finite step, let's say 5, 10 steps, right? A finite and a definite number of steps to get the output or to reach the solution. The last one is output. After the instructions are executed, the user must get the desired result. So after writing an algorithm, you have to get the desired result, otherwise the algorithm will not be valid, or it will be a type of useless algorithm. Some examples of algorithm, I have taken this from the book. You all can refer to the book, page number 44, 45 and 46. Half of the page in 46. So some examples are over here. Example number 1, algorithm to pack your school bag. You can see there's a step-by-step process to pack your school bag. Open the bag. Step number 2, take out your school diary. Number 3, see the timetable. Number 4, go to your bookshelf. Number 5, take out the books and notebooks. Number 6, keep them in the bag. Number 7, close the bag. So finally you have packed your bag. So these are the steps to pack your bag. You can call this is your algorithm to pack your bag, which we do every day, which you all do every day while coming to school. Example number 2, algorithm to calculate the sum and average of 3 numbers. So whenever we are doing any mathematical problems, there are steps. So we follow certain steps. We cannot straight away jump to step number 3 from step number 1, or we cannot straight away jump to conclusion. There are certain steps. So first thing is input the first number. So input, when you are doing this in a computer, input the first number that you have to do. You have to have the number. We have discussed this earlier. So A, we have talked about variable also. So A over here is a variable. Step number 2, input the second number. So you are performing a calculation and you're trying to find average of 3 numbers. So you have to have 3 numbers over here. Is B. Second number is B. Input the third number. So in this way we are giving input of 3 numbers. After that, in order to find the sum, we need to use the operator. You can see step number 4, find the sum of 3 numbers, A plus B plus C. So now A plus B plus C. So this will give you the total of 3 numbers which you have input. Number 5, find the average. So if you are finding an average, A plus B plus C, that total will be divided by 3. You can see over here, everyone. Step number 6, print the average, right? Step number 7, it's handwritten there, print the sum, because print the sum is not mentioned in the book. So print the sum. So in this way, step number 6 and 7 gives the output depending on the previous steps. That is, step number 1, 2 and 3 will give the input. Number 4 will add 3 numbers. Number 5 will find the average of 3 numbers. And then finally, number 6 will print the average. Number 7 will print the sum. Example number 3, you can see algorithm to make a grilled sandwich. All right, there are steps. Straight away you cannot, make the sandwich. All right, you want to have a sandwich. Now you just have a bread, this, that, and then you start making a sandwich. It is not that. You have to follow again certain steps. So step number 1, take 2 bread slices and chopped vegetables. You all know that. After that, step number 2, spread butter on the bread slice. Number 3, for slices, bread slices. Number 3, keep the chopped vegetables between the bread slices. All right, so you'll have to do that. Number 4, grease the toaster with oil. If anyone has tried this at home, it'll be very easy. You all know how you've done it. Number 5, place the bread sandwich in the toaster. Number 6, switch on the toaster and grill the sandwich. Number 7, when the sandwich is ready, serve it hot. So this is the steps for making a grilled sandwich, or we can call algorithm for making a grilled sandwich. Example number 4, algorithm to compare 2 numbers and find the greater one. So here we are comparing the 2 numbers and we'll find which one is greater. So steps are already written. Step number 1, you can see input 2 numbers and store them in A and B. Again, A and B is a variable. Let's say, for example, you have entered 2 for A and 3 for B. Step number 2, check whether A equals to B. If true, then go to step 3, else go to step 4. So the steps are already written over here. So if A equals to B, so we have entered 2 for A and 3 for B. So this statement is wrong. It will jump to step number 3. If the statement becomes right, it will jump to statement number 4 or step number 4. Print both the numbers are equal and stop. Now if A and B are equal, it will print both the numbers are equal and then it will stop. It will stop in step number 3. But in our case, as I've told you, I've given the value. All right, so A equals to 2, B equals to 3 means, so we'll jump to step number 4. Compare A and B. If A is greater than B, go to step 5, else go to step 6. Now this case is also wrong for us because A is not greater than B, the value which we have, which I have told you. So at this moment, it'll jump to step number 6. Print B is greater and stop. Step number 5 is not required over here. But then if the value of A is greater, at that time it'll print step number 5, A is greater and stop. So when you are doing this as a program, you'll have to assign the value for each variable. This is just a step shown how to do it. This is the exact step which we'll follow when we are comparing the number. Later on, when we'll come to the programming, at that time I'll explain you how to do it and then how this algorithm is helpful at that very moment. Thank you and have a good day. Another video will come up shortly.